Welcome back, Physics 40B. This is week 2. This is a week 2 series of explainer videos. Week 2 we talked about fluids, and in the second bullet point for the learning objectives, it's saying that we're going to apply the conditions of fluid statics to buoyancy problems, and that's basically what number 49 consists of. That's the problem that I'm assigned, and that's the one that I'm going to show you guys today. So let's get right into it. The question states, what kind of bear is best? And that answer is black bear. Not just playing. But anyway, so it's saying that the density of the body of a fish is 1,080 kilograms per meter. And to keep from sinking, the fish has to increase its volume by inflating an air bladder known as a swim bladder. By what percent must the fish increase its volume to be neutrally buoyant in water? So the term neutrally buoyant basically just means that the density of the fish has to be the same as the density of water. And since it says that we're in freshwater, we know that the density of the fish has to come down to 1,000 kilograms per meter, because that's the density of freshwater. So we have that written down here, 1,000 kilograms per meter, and that's the density of the fish. So this is like basically explaining what I said earlier. For him to be neutrally buoyant, he has to have the same density as freshwater. And since we're not given any mass or volume in the question, we could use like a series of these equations that explain the relationship between mass, density, and volume to figure out how much he should expand. But since we're not given density, or we're not given masses and volumes, it doesn't make sense to use those. So basically what I came up with was this equation: the density of the fluid that he's in, which is fresh water, minus the density of the fish, and then you divide that by the density of the fluid, because the density of the fluid divided by the density of the fluid is just 1. So if you subtract the density of the fish from the density of the fluid, you'll get a percentage. And then basically this is the math right here. You get about 0.08, which is about 8%. And that's basically it. All he has to do is inflate himself about 8%, and he should be neutrally buoyant, and he should be able to swim away like any other day. Cool. Thanks, guys.